In this video, we'll be going over the answers for Thursday, April 2nd. And we're going to continue on with our topic of work, energy, and heat, and how they're all related. So our first question has to deal with a piston, like the type you'll find inside your car. So let's imagine that you have a piston and it's full with air. And the air inside that piston absorbs 565 joules of heat and expands from initial volume of 0.1 liter to a final volume of 0.85 liter. And while it's expanding, it's pushing against 1 atmosphere. What is the change in the energy of the air within this piston, and is it endothermic or exothermic? So we're doing expansion work, and we have a specific equation for when we do expansion work. And that is work equals external pressure times the change in volume in a gas, or work equals negative P delta V. Remember, whenever you see delta, that's going to be final minus initial. So this is final volume minus initial volume. And when we do this, P will be in atmospheres, V's will be in liters. So our final unit is going to be in atmosphere liter. But we don't want that. We want to be in joules of energy, units of energy rather. And our unit of energy is the joule. And the other equation we need is energy equals heat plus work. E equals Q plus W. So let's take a look at our equation. W equals negative P dV, where it's V final minus V initial. So let's calculate work now. So work equals minus 1, that's our pressure, that's our atmosphere, multiplied by our final volume, 0.85, minus our initial value, 0.1. That means our atmosphere liter is negative 0.75. Don't forget that negative sign in front of our equation. So we need to convert this atmosphere liter to a unit of energy now. So negative 0.75 atmosphere liter, and our conversion is 1 atmosphere liter is 101.3 joules. So our total energy is negative 75.98 joules. So that's a J right there. So we have work and we have heat. We have to figure out if the value of heat is positive or negative. Since the heat's being absorbed, that means it's positive. If you're taking heat within yourself, that's positive heat. If heat is leaving you, that's negative heat. Also, endo, exo, if heat's entering you, endo, if heat's leaving or exiting you, exit. So positive heat, endothermic, negative heat is exothermic. So E equals 565 minus 75.98, and I just rounded it here. Our energy is a positive 489 joules. All right, question 2. So here we have a combustion of acetone, which is nail polish remover. And we have this equation. So the way to really look at this equation, it is saying that we're doing combustion because we're combining something plus oxygen and getting out carbon dioxide and water. Whenever you see something plus oxygen give you carbon dioxide and water, that's always a combustion reaction. No matter what you burn up, you're always going to get like carbon dioxide and water, unless you get like a sulfur compound. And this delta H is how much heat is released when you burn 1 mole of acetone. So that is negative 1790 kilojoules. That's how much energy is released for 1 mole of acetone. All right, so let's say we have a bottle that contains 177 milliliters of acetone. If we blow that up, how much heat is released? Well, the density of acetone is 0.788 grams per mole. So what we need to figure out is how many grams of acetone are in 177 milliliters. And then we need to convert that to moles, because we can see here that 1 mole releases that much energy. So when we take our density, grams per milliliter, multiply it by our total milliliters, we see we have 139.5 grams. If we look up the molecular weight of acetone, we see that acetone has a molecular weight of 58.08 grams per mole. So I take the weight of my acetone, divide it by the molecular weight, and I see I have 2.40 moles. Now this was the amount of heat that was released, kilojoules per mole, so 1,790 kilojoules per mole. I have 2.4 moles. So the amount of energy that is released when I blow up this bottle of nail polish is negative 4,296 kilojoules.